Yeah, good afternoon and a warm welcome to all of you. I am Sandeep and I will be giving you a brief introduction about what is DEP and whom we are. So DEP was founded in 1998 and we are headquartered at Troy, Michigan. And we are having the global offices in India, in China, Japan and Canada as well. So we are having a wide distributors network also. So coming about the DEP, we are into the four main verticals. One is the engineering consulting, software development, where we are having a software known as MeshWorks. Third is the product development, and fourth is the talent acquisition. So you can see the list of offices. The places which are marked in red are our direct offices, and the places which are in blue is our distribution network. So we are having the more than about 500 plus employees across the globe, and we are having like most of the employees are masters and the above rank. So we are present in automobile, aerospace, shipping, electronics, and consumer goods as well. So this is the partial list of DEP customers. It is the combined list of both services as well as we can say MeshWorks software business. And this is the quick brief about our journey. So we were founded in 1998 and we started our Chennai office in 2000. And like in 2007 we moved to a higher space, bigger space, and so on. So you can see, like we started our Brazil operations in Brazil and Japan operations in 2016. So we opened our office in California as well in 2017, and we started our third office in India, like in Bangalore in 2019. And like on the more journey goes on and we are growing. So I will ask Abdul to take over.
Yeah, thanks, Sandeep. Thanks for a very brief and nice introduction about DEP. So with that, so we saw like how DEP has grown so far. So we just wanted to expand our today's webinar series mostly into MeshWorks. So I myself, Abdul. I'm taking care of all the pre-sales and post-sales activities for Asia Pacific zone. So with me, my colleague Ausaf and have joined for live demonstrations. So today's main topic is about fast design iterations using our robust CAE parameterization approach. So mainly like we are going to look into our DEP MeshWorks preprocessor. So to give overview about MeshWorks, MeshWorks is an integrated CAE platform. So where you do all the CAE activities and also post-processing and also pre-processing. So where we have our distinct 10 different modules as integrated into MeshWorks itself, starting from meshing and model assembly, time saving in MDO. So from there, with advanced post processing and CAD and CAE morphing, and with the help of CAD and CAE morphing, how one can able to do CAE parameterization. So which is what we are going to see in today's session. So how one can do parameterization with design, shape, gauge, material, or any other design enablers, etc. So that is what we are going to see in for today. So with the help of CAD and CAE morphing and parameterization, we can achieve multidisciplinary optimization. So I'll touch on MDO as well in the last. And our main unique workflows are our AML CAE framework. Along with that, like we have our highly automated process automation being developed and integrated into MeshWorks. And we have our patented technology of ConceptWorks, which is for all the different verticals of models. And also we have our innovative ROM module. so which is reduced order module, and also product electrification module. So both has been integrated into MeshWorks 24 in the recent days. And so we also use all these verticals of modules in different verticals of industries, starting from automobile industry, aerospace industry, ship industry, oil and gas, biomedical industry, and heavy industries, logistics, and also electrical and electronical goods. So with that, so this is about overall about MeshWorks, and so how MeshWorks is impacting in our design development cycle. So it's a product development cycle. So there is a current trend and a new trend. So new trend is our MeshWorks trend, and current trend is the regular CAE framework. So where we spend a huge amount of time in detailed virtual validation and maintenance phases, whereas in like we doesn't spend any time in the conceptual state, so which leads to spend more time in these different verticals. But whereas in in MeshWorks, like we only spend in conceptual stage, and we spend very minimal man time and machine time in detail the stage in virtual validation and maintenance phases. But in order to achieve all these four verticals of product development, like MeshWorks support MeshWorks morphing and ConceptWorks module in conceptual stage itself, and also in detailed phases, like we can use our CAE parametric approach, which you will be seeing in as a live demo for today, and also topology optimization modules. And overall, like our MeshWorks meshing and model assembly modules, which has been for all these four verticals. And so this webinars has been already detailed webinar about meshing and modeling activities has been done in the past, so which you can able to see from our YouTube channel as well. And for today's main live demonstration, like how one can able to achieve the shape parameterization, bead parameterization, bulkhead parameterization, and doubler, rib, weld, and parametric optimization success stories, etc. So all these one can able to achieve with our fast design iterations. So with conventional CAE approach, so whatever like you see in our market, like how one do develop the design is starting from the CAD design, do the CAE modeling. From there we go for the analysis, and if the targets are met, we freeze the design. If not, again we go to the CAD design and do all the changes and execute these entire workflows one more time. But in the transform CAE, or which is MeshWorks route, like you can able to import your CAD model and do the meshing, etc. So instead, like you can directly import our CAE model itself and do all the processes in the analysis stage. If the design targets are not met, you can able to achieve the design targets by our parametric CAE approach and also DOE optimization approach. So not only like we do morphing and parameterization in mesh level, we can also do that in CAD morphing level. So if you are having a CAD or if you are having a mesh, so anything is fine, like we can able to do that. And also one more advantage here is, so whatever you do the modification in the mesh level can be imposed directly into CAD level as well. So that is also one main criteria in our transform CAE approach. So here the whole lot of 9 yards of meshing modeling activities has been completely eliminated. And also with our new ROM capability in this kind of approach gives more hands for the user. So we do that in an assembly level and also component level as well, or any sub-assembly level of optimization also, okay, with a similar approach. And so in this kind of a parameterization and optimization, like how one can achieve the fast design iterations with these verticals of parameters can be obtained in MeshWorks, starting from shape parameters, where one can able to do any kind of shape modifications on the model or geometrical changes, and then like we can able to play with the material and also the type of material and also the gauge, which is the thickness of the model, and also the weld as a parameters, like multiple number of welds can be reduced or increased, or so the material of the welds, so etc can be parameterized, and adhesives as a parameter, and some of the feature parameters like beads, bulkheads, darts, etc. So that is also like you will be seeing in for the live demo for today, and also some special parameters like part extension, etc. And with that, I'll leave the stage to Ausaf for the live demo session, and from there I'll continue with the rest. Yeah.
Yeah, thank you, Abdul. Hi everyone, greetings. I'm Ausaf. I'm from DP Global Support, and I'm working as MeshWorks technical support for Asia Pacific zone. Now we are going for live demo. We are seeing shape parameters first. So in parameterization panel, we have shape parameters, and in shape parameters we have multiple options. So for a shape parameter, we need a morph setup. So we'll create a morph setup first. We'll create a morph setup for translate. So I'll select this as my control nodes. And I have given two layers for deformation. And I have created a morph set. Now I'll go for shape parameters. And translate, I'll select my morph setup here. I'll give direction as upwards. So we can move these elements in upper direction. I'll set my value. I'll save this parameter here. So I'll go for review. You can see translate parameter. Here I'm scrolling down, so it's decreasing, and I'm scrolling up, so it's increasing the length. So you can see these features also has been captured. So in this way we can do translate parameter in shape parameters. Now we'll do one offset parameter. I'll create a offset for that. So now I'll go for offset. So here you can see our offset parameter here, how nicely it's offsetting the elements, this particular region. So in this way, one can create parameters by using MeshWorks in the shape parameters. Now we'll go for some of the feature parameters. In that we have multiple features. First we'll see bead. We have bead parameter here. So we'll first select the component. We can create a bead as a new feature, and from existing feature too. We'll see new feature. So we'll select the base component. I'll select the length of the bead. And these are some bead inputs. Here we have bead type, 4 types here. And in dome type we have curve and linear. So we can preview our bead, and I will click on accept. So we create beads for the stiffness of the component. If we want more stiffness, we can create a parameters for that beads. So in parameters, I will go for number of beads. And I will as it's in x-axis, I will take x-axis and the negative direction. So I can create my parameters in opposite direction. I'll go for range of 100 or maybe 200. I will define my bead parameters here. So after previewing, you can see we have got 3 as our range is more, we it extended. So after preview beats, we can preview 3 beats here. So in this way, we can you can save this and you can review that. You can review those here. I will take as 2 bits. So you can see 2 bits here. Preview bits. So in this way, we can create a beats. And now we'll see another one, which is a bulkhead parameter. For creating bulkhead, I will select components, 3 components. So we have bulkhead parameter here. I'll go for create, specify geometry. So for creating bulkhead, we have 2 types, between 2 channels and in a single channel. I want to have thickness for these 2 channels, so I will create a bulkhead in between this. So I'll select this as my upper channel and this as my lower, and I'll go for create plane. I'll give the plane size and I have selected the center node. So now I'll click on create. So you can see a bulkhead has been created here. And if you see here, we have connections also. The connection at upper channel with spot weld and adhesives. The same way we have a connection for spot weld and adhesives for lower channel also. Now I'll go for specify property. I'll select this component for the property of bulkhead. Accept. Now I'll specify my connections. We have multiple connections here. For spot welds, we have 4 types. I'll go with that core created lines. And in weld type, we have multiple weld types. I'll click on preview weld points. So you can see we have got weld points here for that particular bulkhead. And after previewing welds, we can see welds have been created here for that particular bulkhead. And I'll click on accept. If I want more bulkheads for the more stiffness of this component, we can do the parameterization. So in parameters, I will go for number of bulkheads. I want 2, so I will give 1 to 2 max and current to 2. So after clicking on preview geometry, we will get 2 bulkheads here. So you can see we got 2 bulkheads with a range of 100 mm distance. So if you want, you can change the direction of bulkheads also. So after clicking on preview with connections, we'll get connections for these bulkheads with welds. So you can see here we got connections. So you can save this, and then in the same manner you can review those also here. So now we'll see one of our feature parameter, which is doubler parameter here. So doubler also we'll use for stiffness. It's just as like a bulkhead. I'll create a doubler here for this particular component. As I have selected the elements, I will restore them, and I'll create a plane. So my plane has been created here. Now we have create doubler in 2 types, along master normal and reverse master normal, and these are the doubler inputs. And here we have weld line inputs also. For co-created weld lines, we have 2 methods, and I will click on preview. Now you can see our doubler has been previewed here, and I will click on accept. Doubler geometry created. Now I'll specify the property for this doubler. I'll select this component. Now I'll specify the connections. I'll go for in spot welds we have 4 types. We have seen in bulkhead also. So I'll go with at co-created lines. I will select this as my connecting part and I'll click on preview. So it says one component specified as connecting parts. So you can see our weld points here, and after clicking on preview welds we got our welds here. I'll click on accept. So we have created one doubler with welds. Now if I want more stiffness for this component and more number of doublers, I will create a parameterization for that. I'll go for number of doublers and the range of 300. If I give positive, it will come in this direction. I will give negative, so I can get a doubler here. I want 2 doublers. Go for negative. So you can see we got 2 doublers with connections. You can save this and you can review this here in review panel. So in this way we can create number of doublers for our stiffness. Now we will see our tetrip parameter for the solid ones. So in parameterization we have a tetrip parameter. So for creating tetrip we need a 2D component. So I have internally created this 2D component by taking face of this solid one. So I'll select my 2D and I need to define my plane where I need to create my tetrip. I'll select my plane and I need to select a center node. So our plane has been created here. So I need to select the trajectory. So in which direction our tetrip should generate. So I'll select my trajectory. I'll sketch my array by selecting my endpoints. As we have entered 4 here, we got 4 intermediate points. You can modify this curve by just clicking on those points. Accept. So as it's we need a solid tetrip, I have check on this convert to solid rib, and user can create a fillet too. So I'll click on preview rib profile. So now we got a 2D rib profile here, and when I click on tetrip preview tetrip, we'll get a 3D tetrip here with the fillet. And if user wants to remesh the fillet, he can remesh the fillet by using remesh fillet option here. So you can see here we got a tetrip with this property of the base component, and I will click on accept. So if I want more tetrips in this circular path, I'll go for parameterization. In here we have a pattern methods, 3 pattern methods. As it's a circular one, I will go for circular. And we need to specify a center. I have a center node here for the circular path. I'll click on that and I have defined my pitch value 36. It's an angle of tetrip. So I need 2 tetrips. I'll click on preview rib profile. So the same way we have got 2 rib profiles here. If I go for 3, we'll get 3 ribs here. So you can see we got 3 ribs, and after clicking on preview ribs we'll get a 3D tetrips here. So user can create a tetrip for the whole component in a circular way by using this tetrip parameter. So here you can see we got a 3 tetrips as we have mentioned 3 maximum, and you can save this, and in the same manner we can review this one. If I click a 2 here, we'll get 2 first, and if we click on 3, we'll get a 3. So now we'll see one of our parameter, which is a weld parameter. So here we have a weld lines here. So we'll create a weld parameter on this. We'll go for weld parameter. I'll select these weld lines, and here we can repitch. We have a repitch options here, so we can use pitch percentage, pitch absolute value, number of welds and all. So I'll go for number of welds. So my minimum will be 5 and my maximum will be 75 welds for this particular lines. So I'll click on, I will give parameter name as weld, and I'll click on accept. So if user wants the diameter, he can change the diameter. We have 3 options here. And if user wants heat affected zones, he can click on this. Now we'll review our weld parameter. So here you can see increment we can give as 5 or 8 or 10. Now I have given increment as 5, and you can see our welds has been increased. And if I click on negative, it's reducing. So in this way, we can increase the welds and decrease the welds by using parameterization from maximum and minimum, which we have given inputs. So in this way, we can use parameterization in MeshWorks for creating multiple parameters. So now I'll hand over this test to Abdul.
Yeah, thanks, Joseph. Thanks for very detailed and very nice demos. So let me quickly share my screen and continue with the presentation. So you have all seen the live demos for our fast design iterations with our CAE parameterization techniques as well for each and every functionality of shape parameterization, be it bead, bulkhead, doubler, and rib, weld, etc., etc. So with these, like how one can able to parameterize the model, and also like I have some success stories to share with. So with the parameterization, like we all know, like one can able to parameterize the shape. So, but in MeshWorks, like we also can able to do like with thickness, materials, welds, adhesives, etc. Apart from that, some of the very unique functionality is our design enabler functionalities. So where we address our beads, bulkheads, doublers, etc. And from there, like you have seen our shape parameterization, like which in where like we do parameterize our entire model with this kind of minimum and maximum criteria of parameterization with header height change, rocker width, or be it any kind of model cut and stitch and do the parameterization in some of the local portions or the assembly level, etc. So the possibilities of are numerous, and when it comes to like thickness and material and wells, so these are all very unique way of doing the parameterization in any CAE world, and which in where like I also would like to touch about the extensiveness of design enablers, starting from bulkhead. Like when you create a bulkhead on as a 610 stiffener, or either like for the side impact or some other stiffener component, like you wanted to increase the material strength, like you can include the bulkhead. But how one can able to parameterize the bulkhead is this width and length of the bulkhead or the number of bulkheads, and be it this kind of quick feature creations like the art parameter, or if you have your seat pods locations where your seat comes and sits on the member. So these cross members, if at all we wanted to strengthen it with doublers, so we can able to do the length as a parameter, or number of doublers also as a parameter. So that much variations, like we can able to do it with the parameterization technique. And also we do everything with connections, and with all this, like some of the unique parameterization or part extension parameter, and part contraction parameter. And if you wanted to reduce weight in the model, like we have our punch hole parameter and Taylor welded blanks, like our laser welding parameters for different material fusions about throughout the geometry on the load path members. And also like we do have not only in the sheet metals, like we do have in the tetra models also, the rib parameterization, which also had shown, and some of the topology parameter also, like so which you are not seen in the demo, like which is you can relocate some existing member to a different location with all the existing wells, and the shape is being deformed based on the new location as well. And rib parameterization in the shell level, and also your weld as a parameters, like number of welds in these particular gaps, and length as a parameter, etc., etc. So these are all the parameterization capabilities in MeshWorks. One can able to impose these parameters in one model, and also can replicate the same into all the different verticals. Like if the user is having abacus model and he is having all these parameters ready, he can impose those parameters into crash, NVH, and CFD in MeshWorks. So with MeshWorks, one can able to optimize different verticals of models with various number of design iterations by just generating multiple designs across each domains. And from there, we do our optimization technique with the help of optimizer. So when we create an input-output matrix table, we just send it to the optimizer, either like eyesight, morph frontier, etc. And there from there we do get our optimized design with the response of his calculation. So this is how we do our MDO with this approach. And with the help of MDO technique and parameterization technique, we have achieved a lot of success stories, so which we wanted to showcase in today's session. So one is the case study one, which is on the stent model, which is a cardiovascular stent. So which is a very micron level of a model, which one can already, we have done an extensive DOE optimization on this model with a stent with thickness and taper, etc. So with this, like the model setup like has been reduced to weeks to days, and also hundreds of design alternatives with we have wide varieties of possibility, and the quality and robust way of simulation. So with that, like we have optimized results for this stent model. And for the case study two, so for the multiple parts stacking in the logistic industry, like we just include this bottle optimization. So where like how one can able to stack up multiple models, the parts one by one, so that like it needs to be, the bottom one needs to be more strength when compared to the top. So it's all need to be addressed with this kind of loading capacity optimization. So so with that, like how one create this top load capacity has been increased by 20% more, like than usual loading capacity. So that is one of the success stories. And this is the case study 3 on the recent motor stator optimization, where we optimize the position of the stator and the motor for the more efficient and heat dissipation. And one more optimization success story on one particular mount of a heavy industry frame, like which is has been reduced to 10 mm to 20 mm variations across as a parameter, shape parameter, and some of the width of the cross-sectional profiles as a parameter, etc., has been done in this model. And it performs the same, but we increase the like a performance and also reduce the weight. So overall mass reduction has been reduced to 5% in this model. And this is one of the success stories for a small car development in a US program, like where baseline structure is 233 kgs when it comes to DEP. And with this design changes and also our parametric capabilities, we have decreased a lot of weight, and which is a great achievement. So from 233 to 175 kgs, like which is a 30% of weight reduction in the model has been done, which is very huge in an automotive industry. And with considering all these crash load cases and NVH load cases into picture. And overall, as a CAE pre and post processor, like when it comes to fast design iterations using our parametric approach, like one can able to do multiple design explorations with one single design, and we can able to meet the performance with weight and cost reductions, and also them as a target. And it is a very easy and very effective way of doing the optimization process, which is a proven way of doing the optimization. And at last, overall, in a nutshell, as a MeshWorks, like I wanted to conclude this session with our 4 verticals of domains, which in where like we transform all the CAE and CAD domains of workflows, and wherein like which we accelerate the CAE processes into multiple new inventions with ROM a module as an example, with multidisciplinary optimization included into it, which saves a lot of time and cost. So we innovate a new module, something like our eMod, like a technology like which has been integrated into MeshWorks recently. And at last, with our automated capability, like one can able to automate multiple numerous workflows, like which has been available and all been set into as a standard with our OEMs. So it can be completely automated, and some of the automations has been already set ready, and it has been integrated into MeshWorks as well. So if any questions is there, like you can post us to depusa.com, and also you can email us in this email IDs. You can also visit our website, and so any kind of old webinars has to be revisited, like you can use our YouTube link, which is shared in the chat box. So thank you. Have a great day. Bye bye.